Hi, my name is Nikhil, and I'm a TA for ECS 281, Data Structures and Algorithms. This tutorial is meant for all the Mac users to get fully set up writing code for this class, right? Now, this tutorial is pretty comprehensive. We're going to talk about just basic development setup, Homebrew on Mac. Then we're going to talk about development on Xcode, and how it differs between Intel-based CPUs, Intel-based systems, and Apple Silicon ARM-based systems, right? We'll talk about the distinction between those two architectures. We'll also talk about development using the Visual Studio Code or VScode IDE, which has become a popular choice amongst students. And lastly, we're going to also have a miscellaneous section where I talk about all sorts of tools and tutorials to make you more efficient in this class, right? My sort of mindset I want you to have going into this tutorial is to try to think, hey, how can I be the most effective student possible? How can I be the most efficient engineer possible, right? Becoming accustomed to the tools to do a development job is an important part of actually doing a development job. And I think it's important that you guys spend the time and energy to go through this tutorial and learn everything thoroughly. And when you start a project, right, we have 4 projects in this class. Before you start one of the projects, I would advise you to come back to this tutorial and rewatch it, or at least rewatch a relevant section. And I think that will make all of you far more efficient, and you'll be able to complete the projects far faster and focus on the core of this class, right? We don't want you to, waste your time for an hour because of some annoying Xcode issue, right? We want you to focus on the core of this class, data structures and algorithms. And the point of this tutorial is to make it easier to do that, right? It's to take care of everything in the background, such that you can really focus on the core material of this class. Sorry for the long intro. We're going to get started right away. Here we go. All right. So one of the fundamental things you need is a package manager. Package manager is a mechanism to install and remove software packages, right? And on Mac, that's called Homebrew. So currently I'm on a Intel Mac computer. For an Intel-based Mac, let me show you, let me just share my screen real quick. Right, there's a few, I'll have this document at the bottom of the YouTube description, and I'll also probably upload it to Canvas. But you want to install Xcode developer tools, regardless of whether or not you're using Xcode. You need it for the Homebrew package manager, right? And oftentimes, a lot of you would have already installed this, right? If you install Xcode, it'll ask, hey, do you want to install additional components? And that's this, right? So you want to go to your terminal and run these 3 commands, right? I'm not going to run it personally just because I've already installed it. I don't want to break something. But if you have any issues running these commands, let us know. We'll be happy to help and troubleshoot, right? All right, so you can go ahead and run these 3 commands and get Homebrew installed and set up. It will take a few minutes to install, so please be patient. And that's for Intel, right? All these commands are for Intel. But I also have a separate section for Apple Silicon-based Macs, right? And I'll explain that next. So here we go, into the Homebrew explanation of Apple Silicon-based Macs. Let me stop recording. Okay. All right, so here is my Apple Silicon-based Mac, and now I'm going to show you how to set up Homebrew here, right? So you want to install Xcode developer tools, as I talked about before. You need this for Homebrew. Even if you're not using Xcode, you should install it. Again, I'm not going to run the commands just because I don't want to cause any issues with my previous installation. But if you have any issues, let us know. And the last one. So the last command, just a word of warning, it installs a lot of packages, and you may not need every single package. So if you have an issue with that, it may not actually be a huge issue for this class, but we'd be happy to help you if you post on Piazza. So after you run all these commands, you'll have your package manager set up. You'll have Homebrew set up, and you'll be ready to go with the rest of the tutorial. Yeah, so now we're going to go into the Xcode explanation. So here we go. Stop recording. All right. So this next portion is covering how do you get Xcode set up and use it for EECS 281. Now, it's important that you guys upgrade your software to macOS Monterey, right? Okay, I am switching. Sorry about that. That'll help you do the rest of this tutorial. macOS Monterey and beyond. So if you're watching this in like 2023, macOS Monterey or something after it should be fine. And if not, we'll put a correction in the YouTube description, or we'll put something on Piazza. Don't worry about it. So if you have not installed Xcode for some reason, there's an Xcode installation tutorial on Canvas. If you go to Files, Resources, Xcode installing using PDF, right? So just the sort of basic installation. And usage. Most of the tutorial is inspired by ECS 280. So if you go to this hyperlink, you can also take a look at how they do their tutorial. Obviously, our tutorial is slightly different because we have slightly different requirements as a class, but it's a good backup. So I'm going to walk you through the development for Project Zero, which is ungraded, and how I'd set everything up. Luckily for you, everything I say about Xcode will apply to both Apple Silicon ARM-based systems and Intel-based systems. Every single Mac, essentially. So let's go through this one. Okay. I'm going to create a new project. Command line tool. ECS 281 project 0 winter 2022. Okay. So I'm going to create a new project. So I've created a new project. Now I need to add and create whatever files, right? Now, if I want to add files, I go here, I can right click. You can hit new file or add files, right? You can do either one. But in this class, you want to download some project files from Canvas. You need the Xcode redirect, the spec, the make file, and you need to include the project identifier at the top of every file. All right, let's just do this step by step. So let's go to Project Zero. So Project Zero, the spec is right here, covers how to handle this, and the project identifier is also here, right? We have project identifier.txt, a helpful file that you can download and use. I'm going to download that right away. We also have the starter tar that you can open up and then use. Now, what else do I need? I need Xcode redirect and the make file. So if I go here, I go to resources. Xcode redirect is here. I can download it from there. And how do I get to the make file? Well, let's find the make file together. Oh, makefile.txt. All right. So that's the makefile, right? Now, now let's process all these files. Right? So we've got in the set of files. Let's open up this tar. In EECS 281, we don't give you starter files like you did in 280 and 183. We do that a bit for labs and project zero, but mainly for projects, we'll just give you the, the spec, the project identifier, and you have to go and make everything else. So it's a big step up. So I want to point out a bunch of things. So makefile.txt, all right. So you want to open up makefile.txt and you want to get the makefile from GitLab. So here I go to GitLab. It's right here, right? I'm going to download it. We also need the Xcode redirect. So let's open up this Xcode redirect.txt. And it's right here. So I'm going to go there. Go to Xcode redirect.hpp, download. All right. Now we have all the files we need. We want to move this into Project Zero Starter. Then remove this old one. Also, you want to rename the makefile to just be a makefile, not a text file. And if you want to make sure that this actually went through, what I recommend doing is popping up your terminal. And then going to that project, right, in the terminal. And then you can change it from there. Obviously, it's not here yet because we haven't added it to the project, right? But if we wanted to, so Project Zero Starter, right? It still says makefile.txt. So what you want to do, you want to rename the makefile, because macOS always is assuming the file extension, that you can force it by renaming the makefile and using the mv command. Now for ls, there's no .txt anymore. So that's important, right? It's sort of, yeah, now it says, okay, this is a make file. That's really important though. We've got Xcode redirect, project zero, sample r.txt. So now that we have all our files together, we've got Xcode redirect, project files, make file. Let's add it to the project and let's take it from there. Let's just see where we are here. Now let's go ahead and add all the files. Downloads, project zero start. My mistake. Going to delete that. Now let me add the right files. Okay. So now I'm going to go ahead and add all the files. I'm going to take out this main because we don't need it anymore, right? And I always recommend moving it to trash, not even removing the reference, because that can cause some issues. If you forget that you removed the reference, but you haven't deleted it, it's a whole headache. Yeah, so now we have to make sure, as I said before, we need to add the project identifier at the top of every file. And when I say every file, I really mean .h and .cpp files, not text files. The way you submit test cases in this class is through various text files. I don't mean that you have to put a project identifier in those. All right. So let's get our project identifier. So I have it here, all right? Now I can copy it. and I can go and put it here. Now, let's just go through some Xcode setup, and then I'll talk about setting up Xcode redirect and make files. So whenever you do an Xcode project, you need to modify the targets. So you want to go to the project targets and sorry. Oh, yes, build phases and then compile sources, right? So now you want to make sure that your compile sources only include .cpp files, and in the CPP files, it only has one main function. And the make file is what we use to compile your code into an executable. So that's important there. You want to go to targets, build phases, compile sources. You can also change it just from this panel here, target membership, which I recommend doing. What's next? Yeah, so you may not encounter this issue. So project targets signing capabilities. You don't want to sign it and run it locally. This is mainly meant for iOS development, but we're not doing an iOS development here. It's just the data structures and algorithms class. You don't need to go this far. So you want to go to project targets, signing capabilities. Don't sign. You want to sign to run locally, sign to run locally, and everything's going to work. Yeah, that should be good to go. All right. So now we have to edit sort of the project settings. So you want to go here, edit scheme, and you want to go to run, and you want to go to options. So a couple things, right? So we use text files, we use IO a lot in this class. So it's important that your code is able to, your executable is able to find the text files you need, right? So instead of searching the entire computer, you can specify a custom working directory, and it'll only look in that directory. And you want to make sure that you include the directory where all your files are located. These are not where all my files are located. One second. Yeah, so these are where all my files are located, right? So I want to choose this location, and then Xcode will go and look for text files here. So that's really important. And it's going to make your life a lot easier when you're specifying input arguments to run. Now, this is diagnostic, so this will make debugging a little bit easier. You want to turn on address sanitizer and undefined behavior sanitizer. This will make it a little bit easier to catch bugs. It's not entirely necessary, but I highly recommend it. And now you want to edit scheme, and these are the arguments that are passing on launch. So for project 0, that's -m resize, and we want to get a text file as well, right? And this is redirecting the input into your executable. -m is a command line option. If you watch the Project 0 tutorial, which I highly recommend you do, Dr. P explains this, right? So it's very important as I'm going through this setup. It might be even better to watch the Project 0 tutorial before you go through this Xcode setup. So now you want to compile and run with the visual debugger. Before we can compile and run with the visual debugger, I want to explain Xcode redirect and make files. Let's start with Xcode redirect. So I already have Xcode redirect in my Xcode project. I want to include it here, right? So hashtag include Xcode redirect HPP. Okay. So I include it here, and then there's a couple things I need to do, right? You want to take out the const from the method signature. You want to, you want to call Xcode redirect, obviously, to use it. Basically, this is essential if you want to use IO in Xcode. and frankly, basically on the entirety of Mac OS. If you use Visual Studio Code without the special launch.json we give you, you have to use Xcode redirect as well. It's essentially for all of Mac OS. And you also need to include iOS-based sync with Studio false, and that speeds up I/O dramatically. So all of these are sort of I/O related. And that's the sort of arc with Xcode redirect. Make sure you include it at the top here. Make sure you include it in the main function, and you should be good to go. Now, second part, makefiles. So makefiles are the mechanism we use to compile your code into an executable. But when we give you a default makefile, it's not filled out for you. You got to fill it out. So one of those parameters are unique name. So fill it out, unique name. Then you want to get identifier. Where's our identifier? It's given to us in the spec, right? So, and usually we give it to you in a text file as well. So here it is. And you want to change the executable. We'll tell you what executable it should be in the project spec. So those are the three things you must change. Now there's an optional thing you can change. So you can get the dependencies and then put it at the bottom, right? So if you scroll to the bottom here, there's actually a list of dependencies that you can include. Otherwise, the compiler will go and find it for you. But you can include it explicitly, and it'll make compilation times a little bit faster if you're only editing a couple of files. So let me copy this command. Just make sure I put it here as well. It was a little bit truncated. Sorry about that. Now, let me run this command. Okay. 1 second. Let me get to the Michigan computer science. Okay, so now I'm here in my file, in my local directory. I run this command to get the dependencies. That didn't work for some reason. 1 second. It's a lot. Okay. Yeah. So what I had before is fine. You don't want to include the the percent sign, whatever the official terminology is. So now we've got the dependencies, and I can include it right here. Obviously, I don't have to, but it'll make compilation a little bit faster for you if you're on an old computer, right? And let me just give you sort of the rundown of make commands. I do want all of you to watch this full tutorial, but I'm just going to give you the very basics. So we're in our local directory here. So if I run make, it'll compile the code into an executable, and then from that executable, I can run /project0 and run the code, right? Obviously, I haven't done project 0 yet, so that's why you don't see anything. Make debug creates a debug executable that you can use when debugging and when running valgrind and perf, which are two tools that we'll explain sort of later on, and I'll talk about at the end of the tutorial. Make ungraded will allow you to create a tar file that you can submit to the autograder that doesn't count towards your 3 submits per day limit, right? So you have 3 submits per day, but if let's say you just want to show your instructor, hey, this is what my project, this is where my project is right now. Here's my code. Well, a great way to do that is to run make ungraded, submit it to the autograder, and it won't count against you. And the instructor can pull it up and look at your code, right? It's a lot simpler than sharing your screen and moving up and down and switching between files. You honestly would probably get more help out of that because we could help you a lot more efficiently. So highly recommend every time you submit to the autograder, run make ungraded, submit to the autograder. All right, what's last? I think the last thing is make full submit. So So if you run make full submit here, it will create a tar file, full submit tar.gz that you can submit to the autograder. All right. What is last? There's one more thing we have to do. Oh yeah, I'm going to compile and run it with a visual debugger and show you how to set breakpoints, etc. Give me 1 second while I fill out project 0. I'm just going to get the code from my original tutorial back then. Okay. All this checks out. So here's project 0 in its entirety. I highly recommend you watch the tutorial, by the way, and I will link to it as well. Yeah, so we have everything we want. We specified the input arguments, so the code will use these input arguments to run. And now let's fire up the code, just make sure it works. All right, build succeeded, good sign. Okay, yeah, it works. So let's say you have an issue and you want to debug it, right? Let's look at the get average function, whatever it is. And let's say there's some issue with this. You can set a breakpoint, right? And run the code. It'll stop at this line, and you can step over, step in, or you can hit the forward button, and you can observe how the data changes at each step. I find using a visual debugger is very important, especially because all the projects in this class are single-threaded programs. So using a debugger is quite easy as well. So yeah, if I hit forward, it'll just go onward. And many of you are already familiar with this part because you've used Xcode before. So yeah, that's about all for the Xcode portion of the tutorial. Next, I'm going to go into Visual Studio Code. And lastly, I'm going to talk about the autograder, how that works, how to analyze the output we give you, how many submits you get, how final grading works, etc. And then lastly, I'm going to talk about sort of the miscellaneous guide, the tips and tricks to become the most effective in this class and utilize your time well. All right, but that's it for this portion of the tutorial. Very good. Not bad. Could have been a little smoother. Stop recording. All right. So the next part of this is explaining how to use VScode in this class, Visual Studio Code. Now, keep in mind, there is a slight discrepancy between using Visual Studio Code on an Intel-based Mac versus an ARM Apple Silicon-based Mac. And I'll explain that discrepancy. And we've actually made that a little bit cleaner, easier to navigate. But anyway, let's get right into it. So let me share my screen here. So first thing you got to do, obviously, is to install it, right? You can use the 280 tutorial for that. That should be pretty straightforward. The next thing after you install the IDE is to install a few extensions, Visual Studio Code, Visual Studio IntelliCode, and Code LLDB. So let me pull up VS Code on mine. You can see that I have a bunch of extensions installed, but all you really need is the C++ extension, IntelliCode, and Code LLDB. That should be enough for getting started. Obviously, there's a lot more stuff you can do, like you can install the extension pack, and there's tons of other things. But for the sake of this class, that's all you need. All right. Yeah, so you can create new folders and drop in files or create new ones, right? It's pretty straightforward. So what I'm going to do here is I'm going to basically walk through project 0 in the context of Visual Studio Code. So before we do that, let's download all the relevant project files from Canvas, Xcode redirect, the spec, the makefile, etc. And we have to include the project identifier at the top of every file, right? So let me go and get that. Makefile, let me install it. Xcode redirect. And then you want to go here and also download this VScode files, this zip. All right. So once that's downloaded, now go to the project specific stuff. So project 0, we'll want to download the starter files, project 0 identifier, and the spec. Now that we've downloaded all of our files, let's make sense of these files. So we've got the specification here, right? And this is what you'll use to get an idea of what code to write. We don't give you as many like starter files as you probably got in 280. So it does take a bit more time to architect and write your code. So this is the project 0 starter file, right? Makefile. So let's go and retrieve the makefile and the Xcode redirect from GitLab. Actually, I think I already have it. Yeah, so I'm just going to download it here. I'm going to download the makefile. Now that I've gone and got those two files, I'll drag them over to project 0 starter. What's the last one? I'm missing one. Yes, the makefile. Right, so let me delete the old makefile. Let me rename this makefile. We want to rename it to just makefile. And sometimes it won't properly change to be just a makefile. So you need to go, as I said before, you need to go into the actual directory and make sure you change it to a makefile, not a plain text document. So let's cd out for a second. Project 0 starter. Okay. MV makefile.txt and makefile. This forces it to change the file extension. So now it's a makefile, right? And that's important. Sometimes just renaming it isn't enough. All right, so now we've got all our files together, besides the VS Code. So these VS Code files, I'll explain them a bit later. Let's get everything inside the IDE for now. Open a folder. One second, let me get to my folder. Okay, so I opened up my the folder that I want to create this new project in. I'll create a new folder here, EECS 281 projects 0 VScode. Okay. Sounds good. Now that I've created the folder, I'm going to open the workspace in said folder. EECS 281. Oh, sorry, that's a midterm. Coursework. Okay. So I'll open it here, and now we're in the folder we care about, and I'll start adding all the files. Yes, if we want to go ahead and add the files, I typically just drag it in. Of course, you can probably do it another way as well. So here's everything. All right, now all the files are in there. Now, there's a bunch of things we need to do here. we need to make sure we include the project identifier at the top of every file. So let's go ahead and do that. Now, where's the project identifier? Usually the project identifier will be at the top of the spec. And we'll also usually give it to you in like an external file as well. So here's project zero identifier. I need to go and put this at the top of every .h and .cbp file. So let's go and do that. Now that I've done that, sorry about that. Anyway, now that we've done that, let's tackle the next part. So let's set up, before I get into the Apple Silicon versus Intel specifics, let's set up the makefile and let's make sure we talk about Xcode redirect. Now, for Xcode redirect, you don't have to use it in Visual Studio Code, but I still recommend you using it. In case something happens to Visual Studio Code, you can switch over to Xcode really easily. So for the sake of this tutorial, I'm going to just explain it that way. So there's a couple things you need to do, as I've talked about before. For Xcode redirect, you want to take out the const from the method main method signature. All right, that's already gone. Then you want to include Xcode redirect.hpp at the top of the file, the CBP file. Let's go ahead and do that. Okay, so we included that file. Now what? We want to add Xcode redirect to the main method. You also want to include iOS-based sync with Studio False to speed up I/O. Now what? Now what? Now make files, right? So we have a full tutorial, as I've talked about before, here, and I highly recommend you watch it. But let's just talk about makefile setup. So we want to change the unique name in the makefile. Want to change the project identifier. I'm just going to go and slide and get the project identifier. It's not here. Here. And we want to change the executable. We'll tell you the executable in the project spec or the lab spec. In this case, it's project 0. Now there's an optional part at the end, right? You can run this in the directory where all your files are located, and you'll get the dependencies, and you can put them here. And that'll basically make compilation faster if you've got lots of CPP files. For this class, I actually haven't seen that many people have a lot of CPP files. So it's probably actually not that useful for you. Make sure you take out the %sign here. Okay, so that's the dependencies, right? So you can put those there. You don't have to. And that's about it for makefile setup. So we've set up the makefile, we've set up Xcode redirect. Now let's talk about the tough stuff, the Apple Silicon versus Intel specifics, right? And I'll explain why you don't technically have to use Xcode redirect because we've simplified some stuff for you. So basically the only real distinction that exists here is when you download this VS Code files for tutorial thing, VS Code files, right? Let's open up the zip. Let me zoom in. All right. Yeah, so here I opened up the zip. Here are the two templates. So you want to include these two templates. Check out the README here. You have to put this in your, you have to put this folder in your VS Code UI Explorer panel, and it has to become a hidden folder. You have to rename it to .VS Code. And if you have Apple Silicon, use this one. If you have, Intel, use this one. All right, we've simplified it a decent amount for you guys here. So now let's do that, right? So let me go get the code. I typically just drag it in. There's probably a more sophisticated way, but for my sake, this is what we're gonna do. Okay. I'll copy the folder over. All right. Now we've got the folder there. We want to rename it to .VScode. Okay. Now we want to go ahead and change all the properties. The main difference between Mac and between Apple Silicon and Intel is the CPP properties JSON. Besides that, they're actually very similar, right? The main reason why you don't have to use Xcode redirect in Visual Studio Code is that we have this stdio portion of the launch.json, and that will enable you to not have to use Xcode redirect because it'll handle it itself. You can think of the launch.json as what actually happens, right? When you run the VS Code debugger, it uses the launch.json, right? So it's going to use LLDB. It's going to launch, right? Before launching, it'll call build debug executable, and it'll run a certain program. In this case, we want it to be project 0, right? So, we have some arguments, right? So we can put in some arguments here, hypothetically. Command line arguments that will be passed into the program. We've got the post debug task to clean the workspace. And you might notice these debug project clean workspace, but those are not make commands. Where are those coming from? Those come from the tasks.json. So build debug executable will call make debug. Clean workspace will call make clean, right? The tasks.json is just an extension of the launch.json. And then we can go ahead and fire this up. I think we're ready. Let's see. So anything else we have to do before I show this to you? Let me go and fill project 0 just so we have, because I just downloaded project 0 from Canvas. Obviously, it's not filled out yet. So let me go and get the actual code and we can take it from there. So I've got in the actual code. Obviously, I highly recommend you watch the Project 0 tutorial so you're familiar with everything that's happening on in this file. After that, so we've basically checked off all the boxes here. We also have another tutorial we made last semester that just covers Intel-based VS Code, if you'd like to check that out. Now let's go ahead and show it to you. I'll run the debugger and we can take it from there. Obviously, if you just want to run the code, you can pop up the terminal, make, and then just run it. right? I do want to show you how to run the debugger because that is quite important. All right, so let me run the debugger. You hit run and debug. We've got debug project, LLDB. You want to hit play here. Let's hope it works. Okay, yeah, I didn't set a breakpoint, so that makes sense. So here, let's set a breakpoint at, say, get median at the sorting function. I run this again. And it'll stop here, right? And you've got a couple options. You can step over, step in. You've got the stop button, the redo button, which will just restart the entire debugging session, and the forward button. I'm just gonna hit the forward button. And there you go. Pretty simple. That should be the process for setting up any project in this class and using VScode on a Mac. And I think that's about it for the VScode portion of this tutorial. Next, I'm going to probably talk about the autograder and then the miscellaneous guide stuff. We're at the end, pretty close to the end. All right. All right, so this is the last portion of this tutorial where I'm going to talk about the miscellaneous section. I'm going to talk about the autograder, how to use that as well. So let's get started out with the most important stuff, the autograder. So let me share screen. This is fine. So here we are at the autograder. Well, not yet. So for the autograder, we have autograder 1, autograder 2. Basically, it's 2 servers. We want you guys to load balance between them, make sure they're not overwhelmed and they don't crash, right? That's all. Now, when you pull up the autograder, it'll look like this, right? You'll have your projects. You can go here and see your labs, exams, etc. And you'll be able to submit 3 times per day, right? Typically. And when we grade your projects at the end, we do something called final grading. So we have a few more test cases at the end, and we run each project submission in isolation, right? So an important part of EECS 281 is both memory complexity and time complexity. And when you usually submit to the autograder, not in the final grading period, during the general project period, your submission will be run with other submissions at the same time. So the end result of your score may not be exactly what you would have gotten if it was run in isolation. Usually it's a very small difference, and that's the point of final grading. Once the project deadline is over, we'll run all submissions in isolation and make sure you guys get the score you deserve. Usually it's not a big deal. You'll only go up like 1 or 2% or down 1 or 2%. But it's an extra sort of assurance. Anyway, I explained that part. Yeah, so now let's submit project 0 to the autograder. This is the project 0 that I was talking about from before. Got the full submit tar.gz. You want to check the timestamp. Seems reasonable. And I'll go ahead and upload it. And it'll grade, right? And I'll just go over sort of like the outline of how it looks. It'll give you a style, how the style looks like. We don't grade on style, but sometimes in order for us to help you in office hours, we do like if you follow these suggestions and improve your style. We talk about, there's a section on build warnings and errors. Then it goes through each test case and whether or not you pass the memory and time complexity, the runtime and memory constraints, and how much credit you earned, obviously. And then at the end, we'll have, oh, you've passed all the test cases, earning you X points, right? And we'll also have a section where we grade the test files, and then we'll have your final score at the bottom. So pretty straightforward. On projects, we'll also have some points for memory leaks. So we'll tell you if you have a memory leak. We'll tell you how many bugs you've caught. And as I said before, the overall grade at the bottom. So that's the auto grade. Pretty straightforward. Make sure you use make full submit, and then submit the tar file to the auto grader. Now, the more interesting, I mean, not interesting, but the other section I want to talk about is sort of like general tips and the miscellaneous guide for succeeding in this class, right? So we have Kane, we have a slide deck here that you can look at that explains a lot of our, a lot of the debugging tips that we have, you know, getting your make file ready, val grind, etc. Input redirection, get line, get up long, lots of useful stuff. That's really important for the projects. And I highly recommend you take a look at that. And this is, I intend for this to be sort of like an encyclopedia. So here's, if you want to use Valgrind, here's a tutorial. If you want to use perf, you can check out the miscellaneous guide, the slide deck. Address sanitizer. You can go to the 280 tutorial and take a look at that. And Valgrind is a mechanism to find memory errors. Perf is a mechanism to see how well your code is performing in terms of time complexity, and address sanitizers, similar to Valgrind, in finding memory errors. These are really useful tools for debugging and optimization that I'd recommend. Now, the next part is Linux Kane, rsync, SCP, Linux commands, Linux GDB, Mac LLDB, right? So a lot of you aren't super familiar with the command line, so I highly recommend you take a look at this basics Linux command cheat sheet tutorial, such that you are familiar and adept with the command line and you can modify files quite easily and move around different directories, create directories, delete things, etc. Another thing that you have to keep in mind is that your code is run on Linux Kane and compiled on Linux Kane, right? So it's important that you're familiar with Kane, how to get into it, how to develop on it, etc. So I highly recommend you take a look at that tutorial. Another issue is transferring files to Kane, right? So typically what I recommend is before you submit to the autograder, transfer your files to Kane using two sources, either rsync or SCP. Then make sure it compiles. If there is an issue, debug it, fix it, and then submit to the autograder. This makes sure that you don't waste submits, right? Now, let's say you transferred all your files to Kane, and then there's some error, right? There's some issue. Well, you can just edit it on Kane through the terminal using Vim. So here's a useful cheat sheet tutorial that you can use there. Additionally, let's say you have to debug on Kane, because once you moved all your files over, there was an issue, you edit it in Vim, and now you want to check that it works. You can debug on Kane command line using GDB. So it's important that you got familiar with this as well. And lastly, I think this is the most important, debugging on the Mac command line. Now, my sort of thinking with this is if there's ever an issue with your IDE, you can pop up your terminal, use LLDB, and debug your code through the command line. Who knows, maybe, you know, there's some software update that causes some issues with the IDE, right? It's important to have a backup, and this is a great backup to use in case you have some issue with your IDE. And lastly, GitHub Desktop. So it's important to use version control just to make sure that you can, you have a safe storage place for your code. You can roll back changes if necessary, etc. So I have a document linking to
280's Git tutorial. And I also use GitHub Desktop, right? That allows me to, sorry, I didn't link to the wrong thing. So I also use GitHub Desktop, which is a GUI interface to push and pull commit from Git. And I found that to be pretty helpful. And lastly, you can use GitHub on Cane through the command line. So let's say instead of moving files to and from Cane, maybe you can just push to GitHub and then pull from GitHub on the Cane command line, right? Maybe you prefer that. Maybe that's simpler for you. That's an option here. I've linked to a few places where you can go and get that set up. My sort of like goal with the miscellaneous guide, the sort of the coding tips section at the end of this tutorial, is to make sure that you're familiar with the tools that we have and you have some sort of fail-safe or backup, right? You can't legislate away failure. You should have some sort of backup. I'm not asking you to memorize every GDB command, but you should be familiar with it, right? You should have some idea of how it works. So in case you have some issue with your IDE, you can use GDB, or let's say rsync is not working for you. You can use SCP, right? It's having that sort of redundancy that is important for being the most productive as a computer scientist in this class. We really don't want you to be stuck on some obscure IDE issue when our goal is really to have you focus on the core of data structures and algorithms. And this sort of end section of the tutorial is meant for you to unblock yourself, right? So before you post on Piazza, I highly recommend you come back to this document, you take a look at all this and see if you can resolve your issue. So yeah, besides that, good luck. If you have any questions about this, please post on Piazza, but that's the end of the tutorial.